parabola, ellipse, hyperbola, a pair of straight lines, a straight line, and a point. These are all the conic sections. So in these conic sections, today we are going to discuss about parabola. First, we have to discuss what is a conic. Conic ante ఏంటి first? Conic ante the locus of a point moving on a plane such that its distances from a fixed point and a fixed straight line in the plane are in a constant ratio E is called a constant. That means so let us take a point S in a plane and a fixed straight line. Let this as L. So this is a fixed point and it is a line, straight line. The locus of a point, for example, let's take a point P. The locus of a point is moving on a plane such that its distances. So అంటే ఇక్కడ P అనే పాయింట్ తీసుకున్నాం. ఈ P అనే పాయింట్ నుంచి డిస్టెన్స్ ఇక్కడ ఉన్న S కి P కి ఉన్న డిస్టెన్స్ అట్లే P నుంచి ఈ స్ట్రైట్ లైన్ కు ఉన్న డిస్టెన్స్ దట్ ఈస్ S నుంచి P కు ఉన్న డిస్టెన్స్ SP. సో P నుంచి స్ట్రైట్ లైన్ కు ఉన్న డిస్టెన్స్ లెట్ దిస్ as M point M. So the distances of the point P from the fixed point and fixed line are in a constant ratio, that is SP by PM is equal to, we are saying constant as E. So then the locus of this point is called a conic. సో P అనే పాయింట్ ప్లేన్ లోకి తీసుకుంటాం. ఈ P అనే పాయింట్ నుంచి ఈ ఫిక్స్డ్ పాయింట్ S నుంచి P కున్న డిస్టెన్స్ కి అట్లే ఈ P నుంచి ఈ ఫిక్స్డ్ పాయింట్ M L కున్న డిస్టెన్స్ ఈ రెండింటి మధ్య రేషియో అనేది కూడా మనకి ఎప్పుడైతే కాన్స్టెంట్ ఉంటుంది. సో దీన్ని మనం సో ఇట్లాంటి పాయింట్స్ అన్ని మనం తీసుకుంటే సో దాన్ని మనం కోనిక్ అని అంటాం. అందులో ఇక్కడ ఉన్న కాన్స్టెంట్ ఏదైతే ఉందో SP by PM ఈక్వల్ టు E. ఇఫ్ E ఈక్వల్ టు 1, ఈ కాన్స్టెంట్ రేషియో 1 అయింది అనుకోండి, దెన్ ద కోనిక్ ఈజ్ కాల్డ్ ఏ పారాబోలా. సో అప్పుడు ఈ కోనిక్ ఏమంటాం మనం? పారాబోలా అంటాం. సో ఇట్లా the locus of all these points, locus of the points is called a parabola when if E equal to 1, conic is called a parabola. Next, if E is greater than 1, if this constant ratio is greater than 1, then the conic is called hyperbola. So అంటే SP by PM ratio equal to E. If E value is greater than 1, then the conic is called hyperbola. So if E is less than 1, SP by PM ratio is less than 1, then the conic is called ellipse. Okay. So today we will discuss about parabola. Okay. So standard form of the equation of parabola in standard form. The equation of parabola in standard form. So this is the important question we will get for 7 marks. So first of all, we draw the diagram. Here, one more thing we have to discuss that yes, once again, the locus of a point P moving on a plane such that its distances from a fixed point and a fixed line in the plane or in a constant ratio E is called a conic. So already discussed it. So, so such P, the locus of the P is called a conic. అలాగే ఆ యొక్క రేషియో ఈజ్ ఈక్వల్ టు 1 అయితే we will call it as a parabola. అంటే that is SP by PM is equal to 1. That implies SP equal to PM. సో S నుంచి P కున్న డిస్టెన్స్, P నుంచి M కున్న డిస్టెన్స్ 1 అంటే ఈక్వల్ అవుతుంది. దెన్ ద కోనిక్ ఈజ్ కాల్డ్ పారాబోలా. సో అయితే ఇందులో ఈ డెఫినేషన్ లో మనం ఇక్కడ ఫిక్స్డ్ పాయింట్ అని ఏదైతే చెప్పినామో ప్లేన్ లో, సో దిస్ ఫిక్స్డ్ పాయింట్ ఈజ్ కాల్డ్ ద ఫోకస్. So and also the fixed straight line ఏదైతే ఉందో it is called directrix. సో దీన్ని మనం డైరెక్ట్రిక్స్ అంటాం. The fixed point is called focus and the fixed line is called directrix. So the equation of parabola in standard form. So మనం diagram target ఒకసారి. This is the directrix and this is the point, fixed point S, focus, and this is L. So let us take a point P. So the locus of the points. సో ఈ పాయింట్ నుంచి లైన్ నుంచి కూడా ఈక్వల్ డిస్టెన్స్ ఉండే పాయింట్స్ అన్ని కూడా మనకి పారాబోలా మీద ఉంటాయి. ఆల్ ద పాయింట్స్ లై ఆన్ ద పారాబోలా. So through S, we will draw a line. Here also draw a line parallel to directrix. So let the point of intersection of these two lines as A. So let the point as P x1 y1. Now let here you have a point that is Z. This is the projection of S on Z, and M is the projection of P on the directrix. So here observe that since SP equal to PM, SP equal to PM, here the point A also lies on the parabola. A also lies on the parabola. That is, A is equal distance from S and Z. So therefore, A is the midpoint of the SZ. A is the midpoint of the SZ. And let the projection of P on the line as n. సో దీని యొక్క ప్రొజెక్షన్ P యొక్క ప్రొజెక్షన్ దీని మీద n అనుకుంటున్నాం. సో తర్వాత ఇక్కడ SZ ఉన్న లైన్ దీన్ని మనం ఎక్స్ యాక్సిస్ అనుకుంటున్నాం. సో ఏదైతే మనకు ఏ నుంచి ప్యారల్ గా డైరెక్ట్రిక్స్ కి ప్యారల్ డ్రా చేసిన లైన్ విల్ టేక్ ఇట్ యాజ్ y యాక్సిస్, x డాష్ y డాష్. So from the figure, S is a point on the x-axis. Now observe here. Here this is the x-axis. We are assuming x as the x-axis, sz along x-axis, and the line passing through A, which is parallel to the directrix as y-axis. So the point of intersection of x-axis and y-axis, that is A, so which is origin. So point of intersection of x-axis and y-axis is origin. So we will call it as vertex of the parabola. And also here the line which passing through the focus is called the axis of parabola. So మనం దీని axis of parabola అంటాం. So since A is the midpoint of SZ, so we have SA equal to AZ. SA equal to AZ. And let, so the distance of A from S as A, small a, that is SA is equal to small a. So then the coordinates of S are, so we are taking S is at a distance of small a units, then the point S is given by small a comma 0. Since it is on the x-axis, the point S lies on the x-axis. The coordinates of S are a comma 0. And since A is the midpoint of HZ, or you already have SC equal to AZ. So the distance of Z from A is also small a. So then the coordinates of Z are minus a comma 0. So by the definition of the parabola, we have SP by PM. SP by PM is equal to 1. That implies cross multiply SP equal to PM. PM means so the distance, the perpendicular distance from the point to the directrix. Here, PM means the distance of the point on the parabola from the perpendicular distance of the point from the directrix. That is PM. Okay. So let us write the distance PM. PM is equals to. So PM here from the figure, observe that PM is equals to Zn. PM is equals to Zn. So what is the length of Zn or Mz? PM is equals to Nz. So Nz, observe here, Nz is equal to Na plus Az. Here we have Na plus Az. Na plus Az. Na, what is the length? Na. Can you guess? An or An. What is the length An? So from the point P x1 y1, you observe that x1 denotes the distance of the point from y-axis. Y1 denotes the distance of the point from x-axis. So you observe that since n is the projection of P, so n is at a distance of which is equals to the distance of P from the y-axis. సో n అనేది ఎంత డిస్టెన్స్ లో ఉందంటే P y-axis ఎంత డిస్టెన్స్ లో ఉంది, that represents the x coordinate, that is x1. So here n is also at a distance of x1. So that is here an equal to NA equal to x1. So this is NA is x1 plus AZ. What is AZ? Here SA equal to AZ and SA is small a. Similarly, AZ is also small a. So therefore, PM is equal to x1 plus a. So this is the perpendicular distance from the point to the directrix PM, that is x1 plus a. Now from this equation, from 1, SP equal to PM. So squaring on both sides, we get SP square equal to PM square. So SP square means the distance between the focus and point. So already we have focus S as a comma 0 and P x1 y1. So since the distance formula we have square root, by squaring we will get cancelled. That is SP square is x1 minus a whole square plus y1 minus 0 whole square equal to PM square. PM we have x1 plus a, x1 plus a whole square. So by simplifying, we will get x1 square plus a square minus 2a x1 plus y1 minus 0, that is y1 square, which is equals to x1 square plus a square plus 2a x1. So on both sides, cancel the similar terms, x1 square, a square, a square. The remaining terms are minus 2a x1 plus y1 square is equal to 2a x1. So by taking the minus 2a on the right side, we will get y1 square equal to minus x plus, that is 4a x1. So the locus of the point px1 y1, the locus of the point px1 y1 is called the locus of the point px1 y1 is called the parabola. Therefore, the equation of the parabola is given by y square equal to locus of parabola. Locus of the point is given by y square equal to 4ax, which is the equation of the parabola in standard form. So this is the equation of the parabola in standard form. So మళ్ళొకసారి చూడండి. Equation of parabola in standard form. So here diagram is compulsory. We will get 1 mark for the diagram also. Let S be the focus and L equals 0 be the directrix of the parabola. Let Px1, y1 be a point on the parabola. M comma Z be the projections of P and N. M is the projection of P and Z is the projection of N of P and sorry. M is the projection of P and Z is the projection of S on the directrix respectively. Let N be the projection of P on the SZ. Let A be the midpoint of the SZ. Therefore, A lies on the parabola. Since A is the midpoint, SA equal to SZ. Now, the line. Draw a line YA, Y dash parallel to directrix, which we will take as the y-axis, and the axis of parabola, XA, X dash, is taken as x-axis. Take ZX as x-axis and y dash as y-axis. Then A is the origin, that is the coordinates of A are 0, 0, and let SA small a, then the coordinates of SA comma 0. And since that is the projection of S, the coordinates of Z are minus a comma 0. And PM is the perpendicular distance from the point to the directrix. So then the equation of PM is PM equal to NZ, PM equal to NZ, that is NA plus AZ. That is AZ is NA is X1, AZ is small a. So therefore, by the definition of parabola, SP by PM equal to E, which is equals to 1. So now cross multiply SP equal to PM, and squaring on both sides, we get SP square equal to PM square. So SP means the distance between the focus and point, that is x1 minus a whole square plus y1 minus 0 whole square equal to x1 plus a whole square. So by simplifying both sides, we will get y1 square equal to 4ax1. So the locus of P is y square equal to 4ax. Therefore, the equation of the parabola is y square equal to 4ax. So this is the equation of the parabola in standard form. So next, so we will discuss some definitions. See here. This is the parabola. We already know what is a chord. We already learned in the circle chapter లో chord గురించి మనం నేర్చుకోవడం జరిగింది. Chord means the line segment joining any 2 points on the circle is called chord. Similarly, here chord means the line segment joining any 2 points on the parabola is called chord. So this is chord. For example, the points are PQ. Here PQ is a chord. Let the focus as S. Next, so this is chord. Next, focal chord. Chord. Here PQ is a chord. Next, focal chord. Focal chord means the chord which is passing through the focus of the parabola. So let this as RS. Here the chord RS passes through the focus. So this RS is called focal chord. Here RS is the focal chord. Next, double ordinate. Double ordinate means Let P is a point on the parabola. So the double ordinate means a chord passing through the point on the parabola which is perpendicular to the axis of the parabola. So the chord passing through the parabola which is perpendicular to the axis of parabola is called double ordinate. సో మనకి ఇక్కడ PQ అనేది కార్డ్. ఈ కార్డ్ యాక్సిస్ ఆఫ్ పారాబోలాకి పర్పెండిక్యులర్ ఉంటే దెన్ ఇట్ ఈస్ కాల్డ్ ఏ డబుల్ ఆర్డినేట్. దిస్ ఇస్ డబుల్ ఆర్డినేట్. నెక్స్ట్ లాటస్ వెక్టర్. So lattice vector means I will draw the diagram. For example, this is the focus here. We already here double ordinates which is perpendicular to axis of parabola. If a double ordinate passes through focus of the vertex, focus of the parabola, the double ordinate passing through the focus is called lattice vector. So the double ordinate means it is already perpendicular to the axis of parabola and passes through the focus. Here it is perpendicular to axis of parabola. We call it as a double ordinate. If the double ordinate passing through the focus, then we will call it as lattice vector. So let this as L dash. So here L dash is perpendicular to axis of parabola and passing through the focus. Therefore, it is called lattice vector. So here we have to find the length of the lattice vector. Here, so మనకు already focus యొక్క coordinate తెలిసి a, 0. So let the coordinates of L are also some a, L. So let L is the distance of the point from x-axis. That is a, L. Here we will get a, minus L. So therefore, the length of the lattice vector that is LL dash. So what is the distance of SL? That is small l. And SL dash L. That is L plus L 2L. Length of the lattice spectrum is 2L. Now we will find the small l. Length of the since here L is a point on the parabola. L is a point on the parabola. So the equation of the parabola is y square equal to 4ax. Here L is a point on parabola. L, a comma L lies on the parabola. So now substitute. It is a point on the parabola. This point will satisfy the parabola equation. That is y L square is equal to 4a x means small a. So therefore L square equal to 4a square. Now L equal to square root of 4a square. So that is we will get 2a. So here L equal to 2a. Small l equal to 2a. Then length of the lattice vector. L dash is 2 times of L, that is 2 into small l is 2a, 2 into 2a, 4a. So this is the length of the lattice vector. So length of the lattice vector is 4a. Next. So there are various forms of parabola. We already discussed the definition of parabola. That is, S is a fixed point and L is a fixed line. So based on this point, the position of the point and the directrix, there are various forms of the parabola which are given in your textbook. Y square equal to 4ax. Y square equal to 4ax. So for this one, the diagram is so this is x-axis, this is y-axis, and this is the directrix. In this case, the focus is a comma 0. The equation of the directrix. The equation of the directrix. The equation of the directrix means already we discussed here the equation of the line. So here we have point Z. This is A. The distance of the directrix from the A is small a. Therefore, the equation of the directrix x1 is equal to minus a. Since it is at a distance of small a in the direction, negative direction of x-axis, so therefore the equation of the directrix is x1 equal to minus a. That is equation of directrix. X1 plus a. Since if you write the locus of the point x plus a, equation of the directrix is x plus a, and focus, that is S, is a comma 0, and the vertex a is 0 comma 0. Similarly, we have different types of parabolas. Here in the textbook, so this is the first case, y square equal to 4ax. Next, to second one, y square equal to minus 4ax. Here, the focus is on the negative direction of x-axis. సో మనకి ఇక్కడ రైట్ సైడ్ పాజిటివ్ డైరెక్షన్ ఉంటే ఫోకస్ ఇక్కడ నెగటివ్ డైరెక్షన్ ఉంది. సో therefore the focus is minus a comma 0. So the equation of the directrix is x plus a, x minus a equal to 0. That is, the directrix is at a distance of a units in the positive direction. So therefore, equation of the directrix is x plus x equal to a. So the equation is x minus a equal to. So next, the axis of parabola. So this is the axis of parabola, that is x-axis, and its equation is y equal to 0. And the vertex is a, that is origin. Next, in the third case, y x square equal to 4ay. Observe here, the axis of the parabola is along y-axis. The axis of the parabola is along x-axis. The focus is on the y-axis. The directrix is parallel to x-axis. So in this case, we have focus is 0, comma a. Equation of the directrix is y plus a equals 0, and vertex is again horizon. Similarly, x square equal to minus 4ay. Here also, the axis of the parabola is along y-axis. The directrix is parallel to x-axis. So here the focus is 0, comma minus a. Vertex a is origin, that is 0, comma 0. Equation of the directrix is y minus a equal to 0. So in these four cases, the vertex is origin only, origin. So in the next case, here, this is the vertex, this is x-axis, this is y-axis. So vertex is in the first quadrant, and parabola. Okay, here the axis of parabolic is parallel to x-axis. Therefore, the equation of the here the vertex we are taking as h comma k. Therefore, the equation of the axis of parabola is y equal to k, which is parallel to x-axis. So next, the equation of the directrix is x minus h plus c equal to 0, which is parallel to y-axis. So next, one more case. So that therefore, in this case, the equation of the parabola is y minus k whole square equal to 4a into x minus h. So next case, the equation of the parabola is y minus k whole square equal to minus 4a into x minus h. Observe here the diagram. Here the focus is in the second quadrant. The axis of parabola is parallel to x-axis. The directrix is parallel to y-axis. Here also the equation of the directrix is y equal to k, since it is parallel to x-axis. So the equation of the directrix is x minus h minus a equal to 0. So we have another three cases. You can observe in your textbook. Here the axis of parabola is parallel to y-axis. In the next case, also here the parabola is upwards, and next case the parabola is downwards. So let us do a problem. Problem 1. Find the coordinates of the vertex find the coordinates of the vertex, focus, and the equations of the directrix and axis of parabola. That is y square equal to 16x. So here we have to find the coordinates of vertex, focus, and the equations of the directrix and axis of parabola. Here the given equation is y square equal to 16x. So here we will compare this equation with the standard form y square equal to 4ax. So this is the equation of parabola in standard form. By comparing these two, 4a is equals to 16. So from this, a equal to 16 by 4, that is 4. Here a value is 4. Here a is greater than 0. Since clearly observe here, the vertex of the parabola here is horizontal. Therefore, coordinates of vertex. Coordinates of vertex are a 0 comma 0. Next, focus. This is the first case. The first case, the focus is yes, small a comma 0. Here we already have a value that is 4, 4 comma 0. So therefore, focus is 4 comma 0. Next, equation of directrix. Equation of directrix is x plus a equal to 0. Here we substitute x value, that is sorry, a value, that is x plus 4 equal to 0. This is the equation of directrix. Next, the axis of parabola. Axis of parabola. So in this case, first case, the axis of parabola is x-axis. Axis of parabola is x-axis. Therefore, the equation of the axis of parabola is y equal to 0. Since the equation of x-axis is y equal to 0, therefore, equation of axis of parabola is y equal to 0. So therefore, similarly, we will find one more. We will do one more problem. Find the coordinates of the vortex and focus and the equations of the directrix and axis of the parabola 3x square minus 9x plus 5y minus 2 equal to 0. So this is the equation. This is the given equation of parabola. So for this type of equation, we will transform this equation to the standard form. We have different cases. Now transform the equation into any one of the cases. Then we will write the coordinates of focus, vortex, and equations of directrix and axial parabola. So now we will simplify. Clearly, by observing this equation not passing through the origin, that is vortex, not passing through the origin. So therefore, here the vortex will be h comma k. So now transform the equation. 3x square minus 9x plus 5y minus 2 equal to 0. So from the first two terms, take 3 as common. X square minus 3x plus 5y minus 2 equal to 0. So here 3 into x square minus. Now we will write this this expression into the form x minus a whole square or x minus h whole square form. So for this, x minus h whole square, that is x square minus 2h x plus h square. So we need this form. For that, so there is no 2, we will get right here 2, 2 into x into 3 by 2. So here 2 will get cancelled. So we will get the same 3x. So x square minus 2x into 3 by 2. This is the h value. So for that, to write into the form, we need h square. So we will write add and subtract 3 by 2 whole square. 3 by 2 whole square, add minus 3 by 2 whole square, bracket, plus 5y minus 2 equal to 0. So by using these three terms, 3 into here a square minus 2ab plus b square, x square. By using three terms, we will write here a is x, b is 3 by 2. That is x minus 3 by 2 whole square minus 3 by 2 whole square means 9 by 4 plus 5y minus 2 equal to 6. So now multiply 3 inside, 3 into x minus 3 by 2 whole square minus 3 9 is 27 by 4 plus 5y minus 2 equals 3. So take 3 from the outside, 3 into x minus 3 by 2 whole square, which is equals to minus 5y minus 27 by 4 will become 27 by 4 plus 2. Now simplify on the right side. Here the LCM is 4. That is 20y. 20y plus 27 plus 4 to the 8, which is equals to minus 20y plus 35 by 4. So we will take minus 5 common, minus 5 by 4. So the remaining is 4y by 4, 4y minus 7 by 4. So already 4 taken outside. So here, this one is okay. Here, take minus 5 as common. We will get 4y minus 7 by 4. By dividing with 4, minus 5 into 4 gets cancelled. Y minus 7 by 4. So left side we have 3 into x minus 3 by 2 whole square. Take 3 to right side. We will get x minus 3 by 2 whole square is equals to minus 5 by 3 into y minus 7 by 4. So therefore, this is the equation is transformed into the standard form. So now we will compare with the case. See here we have minus negative x minus h whole square equal to minus 4a into y minus k. So that is here h comma k, x minus h comma k. H value is 3 by 2, comma k value is 7 by 4. So this is the vertex A. Now we are comparing the equation with x minus h whole square is equal to minus 4a into y minus k. So therefore h comma k is 3 by 2, 7 by 4. And next coordinate of focus, that is h comma k minus a. So first of all, we need a value, that is here 4a. By comparing the equation with the standard form, 4a equal to 5 by 3. That implies a equal to 5 by 12. So now the focus is h comma k minus a. Here h value is 3 by 2, comma k, that is 7 by 4 minus 5 by 12. So on simplifying, we will get 3 by 2, comma 21 minus 5. So take LCM here, 12, we will get 4 by 3. So next, the equation of directrix. The equation of directrix is y minus k minus a equal to 0. So y minus k, that is 7 by 4 minus a. that is 5 by 12. By simplifying, we will get, so let's take here LCM as 12, 12y minus 21 minus 5 equal to 0. 12y minus 36 equal to 0. Next equation of, so we can take common here, 12 common, y minus 3 equal to 0. Next equation of axis. Equation of axis is x minus h equal to 0. That is x minus h. H value is 3 by 2. That implies 2x minus 3 equal to 0. So this is the problem. It is very important for 7 marks. First, the given equation is transformed into the standard form. And then we will find the vertex of coordinates of vertex, focus, equations of directrix, and axis of parabola. Okay, that's all for now. Prepare some problems, similar problems, practice the exercise, and learn all the types of parabolas. Thank you for joining.